First of all, from my side, I wish you a very warm welcome to our webinar Lab futureLab. And I'm very pleased that so many of you have registered and dialed in, of course. I'm sure you will get to know some exciting topics from Lab today, and I am already looking forward to your questions and, of course, the exchange of ideas at the end of the webinar. Before we start, I would like to introduce you to the speakers of our session today. So at first, my colleague Susanne Kriecher, she's Senior Manager Business Development of IoT here at LAPP. Then the second speaker will be Martin Dorner. He's responsible for the technology and the innovation management here at LAPP. And at last, Ralf Möbus, he's the head of product management, industrial communication. Yeah, let's jump right away. So with the question, what's behind the concept and the buzzword futureLab? So of course you were all interested in our webinar, and you all asked what's behind this futureLab concept. And so the concept, so I have the answer. The concept and the idea was born within internal discussions about our general development and innovation approach. So we didn't want to have only discussions and sales talks with our customers when the products are ready and finished for the market. We want the active participation and exchange within the development phase with our customers, partners, or suppliers to get insights in customer pains and gains, and problems, wishes, and real requirements. So therefore, we created the concept Lab futureLab, and last year at the Hanover Trade Fair, we had our premiere with this concept. There we presented current development projects, prototypes for the first time, and all with the aim of generating customer feedback at a very early stage of development in order to be able to incorporate this directly into the development process itself. So, of course, we also wanted to gather further impressions and requirements and win active pilot customers for our projects. Last year, we were able to establish this concept very successfully, not only at our trade fair in Hanover, as well as in Helsinki and Nuremberg. And we were able to integrate valuable customer feedback into our development phase, acquired new cooperation partners, and even won active pilot customers for our projects. Since we have to do without the personal exchange at trade fair this year, as everyone, I am very pleased that we are able to transfer this exchange with all of you to the virtual level, and therefore I want to show you now the topics for today's first Digital Future Lab. In the first slot, you will get an insight into our Lab IoT solutions from my colleague Susanne Kriecher. Afterwards, Mr. Martin Dorner will show you our development projects called Digital Cable Code and Cloud Marking. And we will end the webinar with a closer look at the single pair Ethernet network. But for sure, afterwards, I'm looking for your questions and your feedback and the active discussion with you. So right now, let's jump into it, and I warmly welcome and hand over to Susanne Kriecher.
Very good. Thanks, Freya. So warm welcome also from my side. As my colleague said, my name is Susanne Kriecher. I've been working for LAPP for almost a year, and I'm responsible for the business development of IoT. What I'm not going to do today is to go too much into the definition of the terminology of industrial Internet of Things. I assume that most of you are very familiar with the wording. It's more or less about the connection of machinery, of the equipment, of components with sensors to make them smart, to gather information and to derive a lot of information out of the sensor signals that helps you improving the production in total. So Freya, can you give me please the next slide? Thanks. What I want to show you today are two concepts that are related to the topic of industrial Internet of Things, because we as Lab are always also thinking about how can we make the life and the work of our customers easier by equipping components with sensors and by making them smarter. And one of the concepts is our so-called Lab Predictive Maintenance Box. I'm going to explain the details a little bit later, but it's more or less about predicting the lifetime of cables to tell somebody running the machinery in advance that something is failing. The second solution that I want to show you that is more or less already a product sold together with our colleagues from Finland, from Lab Automatio, is the so-called Lab IoT key, which is a very classical IoT solution. Namely, we have a system being equipped with sensors. Those sensors are sending a signal by wireless transmission, the LoRa protocol, to a gateway, and that gateway is then making the data available from everywhere worldwide. That means you can have here a condition monitoring approach for your machinery for various sensor elements. Okay, so Freya, let's start with the lab predictive maintenance box. What we did here is that at the beginning, we were asking our customers, okay, so you're doing a lot of condition monitoring and predictive maintenance in your machinery for motors, for gears, for the equipment itself, also, for example, for the spindles of machine tooling equipment. So what is about the cabling inside your machinery? Are you considering the drag chains? Do you know when something is failing, or what are you doing? And the answer we got was that most of them are doing some kind of reactive maintenance approach. That means they are replacing the cable as soon as something fails, with the hope that the cable is still available in the warehouse. Other customers were giving us the feedback that they have a very critical process, that they are not allowed to do the reactive maintenance. That means they do the preventive maintenance approach. They are defining fixed intervals, and after those intervals of 1 year, 2 year, or 3 years, they are replacing all cables, even if the cables are still good, which is a lot of cost for them, but a more secure way than just waiting for the machine to fail. And our approach now is to have a solution that tells the customer in advance when the machinery is failing due to the cables itself. And that is the so-called lab predictive maintenance box. Okay, next slide, please. On that slide here, you can see a typical setup of a car automotive production line with a lot of robot systems. There are a lot of high speeds, that is full automation. The machinery is normally running 24 hours a day. And the machinery also has to be very small. That means the dress packs where all the cables are in are also getting smaller and smaller. And that is a lot of stress for our cables, or for cables in general, because the bending radius is getting very small and there's a lot of torsion to the frequent movements. Of course, we and also other people are offering a very good cabling, or we are also trying to have a very good cabling that is resistant for all these movements. But if the process is really critical, you can never avoid a failure at some point. That means, for example, the wire is breaking, there's a damage to the chassis of the cable, to the insulation. And in these cases, it is good to know as soon as, for example, for data cables, there's an interruption of the communication or failure on the communication, or for control cables, as soon there's an interruption of the power supply. Okay, next slide, please. So the approach or the setup that we were thinking about is, or that we are currently implementing, is that we developed the so-called lab predictive maintenance box, which is a box equipped with an electronic and sensor systems. And this box is placed in between the application itself, which you can see on the left side of the slide, and the control on the right side of the slide. And the box itself is now monitoring the area that is called stress cable. That means in between of the application, or the application itself, and the box. And we are not looking at the data itself that is going over the cable, but we are looking at specific physical properties of the data transmission. And by degradations or by changes of these data transmission properties, we can then calculate a so-called LAPP predictive indicator, which is a curve that is given in the upper part of the picture on this smart mobile device. And at some point, you're getting an alarm as soon as the lifetime of the cable is going down and as when the quality of the cable is going below a critical value, and then you have to change the cable or your process is not secure anymore. Next slide, please. This slide is showing you a setup of the box, how we are currently using it in first pilot projects worldwide. The box has an inlet for the data cable coming from the application. On the other hand, having an outlet to the control itself, and of course a power supply. The box is equipped with several LEDs indicating the status of the transmission, indicating the Wi-Fi connection of the box, and also in the lower part, the cable status, so-called LAPP predictive indicator. We have implemented different ways of how to transmit our LAPP predictive indicator to the customer's control, either by Wi-Fi, by switching opening and closing device, by IO-Link protocol, by a pulse width modulated signal, by Bluetooth, or directly on top of the existing data connection. So there are different ways of how you can then later on get the lifetime signal. Next slide, please. The benefits that we want to propose to you as a maybe possible future customer for the box, one of our main approaches was to not change the cable itself. That means retrofit solutions are always possible. So there's no change of the cable construction. The only thing you have to do is to plug in the box in between of the data transmission. And it is very flexible. That means dependent on how critical your application is or not, you can change how fast you get an alarm from the box itself. Next slide, please. On that picture here, and what I want to show you is that making a smart solution, you have to be aware of what information is in your data that you are measuring, and therefore we're doing a lot of testing in our test center. At the beginning, we did it in very long direct chains, and here we had the problem that the cables were not failing at all. So at the moment, we're using a short distance setup to really stress the cables and to force them into a breakdown within 24 to 48 hours to enhance the number of measurements we have. Our current scope for the development are Ethernet-based data cables, but we're extending it step by step also to all the other cable types that we have. Next slide, please. What my colleague Freya said at the beginning, for our future lab and for all the topics that are in there, it is very important to be in a very early phase in contact with pilot customers. What we did at the beginning is that we implemented our box in our own logistics center in Ludwigsburg. Here we have a full automated cable drum warehouse, and in this warehouse we have the robots moving in and out the cable drums, and those robots are equipped with our box, so that we can check frequently the status of the drag chains. But we also have a customer, an external one related to that segment, and two other ones which are very interesting, namely from the automotive industry. As I said, here we have a very high automation degree, and as soon as one process element fails due to, for example, cable breaking, then the other processes also stop. And the third pilot customer is from the medical sector, which is also very interesting, because here you always, you never know when a patient is coming and needs some equipment, and this equipment has to be always ready to save human lives. So it's always good to know the status of each component, not only the cables, but also all the other elements being in medical equipment. Okay, next slide, please. So with that, I wanted to give you a short introduction to our LAPP predictive maintenance box. And now I want to give you a short insight into the other product that I mentioned at the beginning, which is the so-called LAPP IoT key. And that solution is meant for monitoring your machinery over very long distances. On the next slide, I can show you the general setup. On the left side, you can see the core element, which is the so-called IoT key transmitter. It is able to be equipped up to 3 sensors for measuring, for example, temperature, vibration, the humidity, the current, or the voltage. And then we are using the very interesting wireless technology of LoRa to transmit the signals with very low energy for very long distances to a gateway. And this gateway is then by GSM, by mobile wireless communication, is transmitting it to a cloud from where you can access it with any mobile device or laptop. And then you see the current status of your machinery regarding the sensors that you equipped our transmitter with. Next slide, please. So that is a view of the dashboard itself that we have implemented to make it easier for you to access the data. It is fully customizable. That means you can you have a pre-design, but then you can adjust the elements how you like it. And you can easily access history data also to see what happened last year, what is happening last month, zoom into single data points and do the general analysis that are normally done when monitoring machinery. What is interesting, but also well known, that if you do condition monitoring, it's always good if you get an alarm, if you're setting values and those values are exceeded, and then you can react instantly and have a look what's happening in the machinery. Next slide, please. So those are here the 3 core elements of our product. On the left side, the core element of the transmitter, which has this encrypted wireless LoRa communication, and we are integrating it into 2 different setups of ready-to-use measurement sets. They're including the sensors, the transmitters, the batteries, the antennas, and the housing. And on the left, in the middle picture on the left side, the blue box is a ATEX housing. That means we can use it also in very rough and explosive environments. And on the right side, you can see then the dashboard and the gateway that is then accomplishing the system. Okay, last slide, I think so. Thank you, Freya. On this slide, you can see 3 of the main industry segments where we are currently using our product together with our customers. So on the left side, we have the oil refinery, where we are, for example, having a wireless temperature measurement for checking the status of the heat exchangers. And the customer here wanted to improve the energy and maintenance costs. And in the middle, for example, you can see a setup of a sawmill. So especially in the wood industry, it is very important to have a frequent control of the temperature, how the wood is stored and how the wood is processed. And on the right side, you can see a water supply network, where it is very important to have a constant check of the water level measurements. And what is in common with all those 3 applications is that the area where you're doing the productions is very widespread. That means that you have to transfer the data signals over a long distance, but at the same time, all those applications do not need the data in real time. And that is also where LoRa is very interesting, because with very low energy, you can transport little amount of data over very long distances. That's why we have chosen that. Okay, and with that, I wanted to give you really a very short insight into our industrial Internet of Things solutions. And then I would like to hand over to my colleague, Mr. Martin Dorner. Thank you.
Thank you, Susanne, for your introduction. And I'm quite happy to present to you right now 2 projects which are covering also the idea of our futureLab, because they are in a quite early development stage. And the intention of our futureLab is to get in contact with customers and maybe also competitors to talk about projects, to talk about ideas, to talk about problems, and maybe also to get a valid feedback if we are on the right track or not. And therefore, I want to present 2 projects in early development stage within the next 15 minutes, which are covering the problem of the connection of digital informations to an analog product, which is in fact a cable or a connector. So first topic is the digital cable code, and coming back to the customer problem, maybe you already have faced this situation that you want to install and assemble a cable and want to attach a label with normally a cable tie. So therefore you know the problem, the space is limited, and also it's a quite time consuming process. So that is one customer problem related to own product marking. And then we also are facing customer problems related to our LAPP products, which we are also delivering to our customer with, of course, an article number printed on it, but in fact, the installer on the shop floor maybe do not have other on-site informations available, also has no technical background information, or for example, no quality proof about the technical measurements of this product. And in fact, he has no product history. So here we have have identified two customer problems where we think that our solution or our idea will help us with a new solution. So therefore, the idea is to provide an unique code, which could be, for example, a QR code, but could be also an alphanumeric code. And this unique code, which exists only once on the world, provides you then a link to a digital page where you can find content and information by LAPP, and also content which you as customer have uploaded it to it. So what would be a suitable application then for both customer problems? The first idea is that instead or additionally to the existing label, you print on your mount on your digital cable code, and you have then the possibility to read the alphanumeric code or to scan the QR code, or also the maybe possible way, the RFID code. And all these three ways provides you then one link to an existing landing page, which exists only once for this special code. And here you can find your information, maybe your circuit plans, maybe your comments to the mounting process and maintenance steps. So that would be an application which would be on the customer side, but we also think about the solution for our products to offer our customer an value. And here for the LAPP product marking, you see our assembled product. We have different informations related to the article number, for example, which is similar for every harness product. These are data sheets, the drawings, and the technical specifications. But then we also have item-specific informations related to a serial number. And this is, for example, the production history of this specific item, and also test protocols for this specific item, which proves that all or technical parameters are okay. So these are informations which we have at LAPP, but actually it's a quite difficult process if our customer wants to have these informations. So therefore also the idea to add this unique code, for example, QR code, directly to the product so that the customer can have access, on-site access to these product-specific informations and item-specific informations directly on the shop floor. That is one benefit for the customer, but of course, behind this unique QR code, there would be also the possibility for the customer that he can add further informations as installation comments, maintenance reports, or for example, circuit plans. So these are ideas, customer problems, and applications related to a digital cable code. And as I have mentioned at the beginning, we are looking for feedback, for honest customer feedback, if we are on the right track or not. And therefore, we would like to ask you to give you your feedback. And Freya, you can start. Yes, the questionnaire. So your feedback about the presented idea is, first topic, is the solution interesting for you and for an existing problem of yours? Do you find that this is an interesting solution, but that you actually do not have an existing problem for this? Or do you also find, and that's fair enough to mention it, that it's an unspectacular solution without any application? So.
Oh, perfect. I will wait 10 seconds more. So the last seconds. It's a very positive result. So there are a lot of participants that think this is an interesting solution for an existing problem.
Okay, that's quite interesting feedback. That's
perfect.
Promising. Sounds good. So thank you for your feedback. And now we continue with the second idea, which is more.
I'll tell you a little bit about our single pair Ethernet activities and without slides now. And single pair Ethernet is one of the major trends in the last years that came up together also with some new standards for industrial communications like OPC UA or TSN. So with single pair Ethernet now we have the chance to bring Ethernet to the edge. That means to bring Ethernet to every single sensor, and this in a very economical way. So you know, for Ethernet today we need at minimum 4 cores, 4 cable cores or 8 cores. Yeah. Now with single pair Ethernet is possible to transmit data with data rates up to 1 gigabit over one single pair of Ethernet. Yeah. So and in the past, you remember, if you look back in the, let's say, last 10 or 20 years in the development of industrial Ethernet, there was only one way, that was the way up. That means the data rates always increased, but at the same time also the effort for installation and
sorry for the short.
I see slides.
Perfect.
So perfect. So could you please switch to the next slide?
Yes, of course. Yes.
Okay, perfect. And yes, in the last years, there was only one way up. Now we are up, can transmit up to 10 gigabits via Ethernet with category 7 cables. And but at minimum, we need 8 cores for this. And this is a high effort for installation, but also for, it could happen that you make failures during the installation. And this is something that single pair Ethernet addresses. So with single pair Ethernet, it is possible to transmit data up to 1 gigabit per second over just one single pair of copper cores. So next slide, please. So with 100 megabit Ethernet, it was possible to transmit it over 2 pairs of copper. One pair is for transmitting and one pair is for receiving the data. Now, and with gigabit Ethernet, it was possible, or is possible, to transmit and receive data on each single pair, but we need 4 pairs of that. With single pair Ethernet, you can transmit and receive data that means bidirectional, on one single pair of copper cores. Next slide. So what is the development of the standards at the moment? Basically, we have a set of standards which are coming from the IEEE and that are standardizing the Ethernet communication for single pair Ethernet. So we have one for 10 megabit, we have one for 100 megabit, we have one for 1 gigabit, and we have one for 10 gigabit. Also, the distance is different between these. Yeah? With 10 megabit, we can bridge over 1,000 meter, which is quite close to the field buses that we know. You know, with standard Ethernet, usually it's possible to transmit via 100 meter. So 100 megabit goes up to 15 meter, 1 gigabit up to 40 meter, and 10 gigabit is standardized up to 50 meter. So most of the standards are already released, but there are two that are still in work. One is the standard for 1,000 meter, which we expect in 2020, and the other one is for 50 or 40 meter for the gigabit, which will also come up in the future. For the cables and the connectors, we have two standards which are coming from the IEC. We have the 63171 and we have the 61156. First one is for connector and the second one is for the cables. Next slide, please. So thinking about applications, single pair Ethernet is a communication standard that is coming from the automotive industry and was originally developed for cars. What we are focusing on is industrial automation. So even if you can use it also for building automation, and there are a lot of developments started now to bring this also in the building automation, but we see a lot of potential in process automation. That means for chemical industry, big plants, where we have the possibility to transmit Ethernet via 1,000 meter in low data rates, which is perfect for simple sensors like analog sensors today. And there's a lot of big potential in the factory automation. In factory automation, since everyone is building up now smart factories, we have a lot of new smart sensors that are directly connected to the network. And now we have a very economical way with single pair Ethernet to attach a sensor directly to the Ethernet network. So next slide. Next, please. Yeah. So this is how we presented single pair Ethernet, our first prototypes at the last HMI fair in Hanover. And we called it Ethernet to the edge, and this is really the idea and the most interesting application that we see, that we bring Ethernet directly to each single sensor. And so at that time there was no connector available, so we used our prototypes cables and to put them on that presenter and attach them directly to the sensor or to a switch. But since connectors are also in work and in the development, I tell you later something about the connector status. Next slide, please. So this is our cable portfolio like it looks today, what we have now in the development. And so this is the first step, and later on we will have also some different cables, maybe for special applications like torsion or something like this. The first cable, T1 FDP, is FD stands for drag chains, and this is a cable for use in drag chains, has a POR outer sheet, and is usable for distance up to 40 meters, and for data rate up to 1 gigabit per second. Second one is our T1 Y Flex. Y stands for PVC cable for flexible applications, and though that can be used for 100 megabit or up to 1 gigabit per second, and the cross section is AWG22, so it's a mid-sized cable. T1 P Flex. The third one, you see this is a much bigger cable, which has a very high cross section. It's AWG 18. So it's made for high distances, and this will go up to 1000 meters with 10 megabit per second. So this will be a typical direct substitution of a field bus today. Yeah. So next slide. So connectors. Connectors are a little bit political at the moment. So since there are several connector types in the IEC standards, the IEC 63171. And on this slide, I have mentioned the three most important standards, connector standards that are in that IEC standard. First one on the left side, this is the -6 connector, which is supported by the SPE Industrial Partner Network. And the second one is the single pair Ethernet Aliens connector, which is supported by this organization. And this is the so-called -2 connector. And both of them have different mating interfaces, so that means they are not compatible. So let's say our interest is mainly to have at the end one connector standard on the market, because having more than one is not good for the market approach and for the developing of the market. We are supporting the first connector, the left one, which is the connector that we want to further push at LAPP. And but if maybe in future another connector standard will also get a market relevance, for sure, then we also offer this to the market. Next slide, please. Power over data line, PODL. This is a designation that was developed, or is a new designation for single pair Ethernet. Means a simple set power over Ethernet for single pair Ethernet, and something that we already know from the normal power over Ethernet cables. This is also something that can be used for single pair Ethernet. Now up to 16 watts can be used for powering cameras or access points or remote IOs. And the normal way how to interconnect these things is we have a so-called endpoint that is industrial Ethernet switch, where we feed in the power, and we have a so-called powered device, which could be this camera, and that is powered via PODL. And another opportunity is to feed in with a so-called mid-span device, which has two Ethernet ports and feeds the power in at a certain place where you cut the cable and put this device in. So next slide, please. So conclusion, Power over Ethernet is first of all an open protocol, which gives us the opportunity to bring Ethernet really to the edge of the Ethernet network, to every single sensor or actuator. Now we can have the data there and get the data from there and bring the data to that devices. And that makes Ethernet now very flexible, usable, and very much more economical than it is today. And it is an enabler for industrial IoT. With industrial IoT, we will see much more smart devices, sensors that have intelligence directly integrated. And so for these devices, SP is the best choice. Real-time communication with TSN. TSN is something that can be used on standard Ethernet, but for sure can be also used for single pair Ethernet. That means also real-time behavior of the network can be used everywhere in the network with single pair Ethernet. Up to 1 gigabit for automation networks, remote power supply with power over data line is also included, and we have a standardized interface. Hopefully, if we have at the end one connector, then we have really a real standard on the lowest field level for the interconnectivity. So thank you for your interest, and so I try to hand over to